Today, we're going to get the REV Color Distance Sensor working, and I'll show you exactly how to use it in Java. As a coach of national champion and Inspire award-winning FTC teams, I know that getting your sensors working correctly is one of the most critical steps to building a competitive and reliable robot. I'm Coach Pratt, and I'm going to run you through the entire process. We'll start with the hardware configuration, and then we'll jump in the Java code to be able to read color and distance values, and we'll finish by building two practical examples you can adapt for your own robot. So looking at our test bench here, I'm going to be using my test bench here. I've got a full video on how you can set this up and 3D print it yourself. If you've already followed through my configuration video, you don't have to follow this next step. You can skip right to the coding section chapter in this video. Otherwise, talk about wiring. This is the REV Color Distance Sensor. It's version 3. If you're using version 2, this tutorial is not going to work for you. You get to go back find one for version 2 specifically. Wiring up's pretty simple. You just take it out of one of these JST connectors, and you come into the I2C port specifically. So I'll move that out so you can see, into the ITC port. Yeah. So once you got into the I2C port, you need to make sure you configure this. You can go ahead and tap the 3 buttons on your driver hub in the meatball menu. Go ahead and select Configure Robot. And I'm using the test bench here, so I'm going to edit this, come to the control hub, and I'm going to come down to the I2C bus. I believe I have mine connected to I2C bus number 2. I have the REV Color Sensor V3, and I've called it sensor_color_distance. I like to use underscore here when I'm talking about specific hardware so I can remember where things are. My European British friends, remember that this is American spelling, so no U in your color. I run into that problem quite a bit. So we're going to go ahead and click Done. We'll save that all. And then the last step, you have to make sure you select Activate. Once you activate, it's going to restart your robot. And that is your color sensor all ready to rock for today. So let's actually get this thing up and running. So when I come in here to my Android Studio, I'm going to go ahead and connect my control hub via a USB-C to USB-A cable. Otherwise, it's not actually going to get connected here. So first thing we're going to do is we're going to break our mechanisms off into a separate package. So inside your team code, I like to add in a package here. And I like to call it the mechanisms package because I keep track of all my mechanisms in specific places in their own classes. It makes your code a lot cleaner instead of having initializing all of your hardware inside of your main OpMode. So inside the mechanisms package, I'm going to go ahead and make a new Java class. I'm going to call this one my test bench color. And so inside of this test bench, the first thing we're going to do is we're going to make a new variable for our color sensor. So we're going to say our normalized color sensor of color sensor is going to be our first. And then we're going to make a list of all of the colors that we're possibly able to detect. So we can return that in a really easy to use value in our main op mode. So we're going to abstract away some of the complexity in our main op mode so we can do it here. So let's go ahead and make a list. In our case, we're going to be detecting 3 colors today. I've got 3 little color chips here. I've got a red chip, a blue chip, and a yellow chip. You're going to have to change your list depending on what colors you're going to be detecting. So over here, I'm going to make a new public enum called detected color. And in here, we're going to make a list in capitals of all the types of colors that we'll be able to do. I'll do red with a comma, blue with a comma, yellow with a comma, and then unknown for another. Of course, you may need to add in a few more of these or take some colors out depending on what the season is. Future Pratt here, forgot to put this detected color as a capital D for our enum as opposed to a lowercase d. Now we're going to make an initialization statement for our hardware here. So I'm going to make a public void init method, and we're going to call this with a hardware map of hardware map so that we can go ahead and pull that in. Inside this, we're going to say that our color sensor is equal to a normalized color sensor. It's equal to hardware map dot get normalized color sensor dot class. And then inside these quotation marks after that comma, we have to make sure we put in the exact name, which was our sensor underscore color underscore distance. If you don't put in the exact name that you've written in your configuration file, this will not work. Then we're going to go ahead and make our getter method so that we can go ahead and actually get what our colors are. We want to return just a straight up value, just so we know if it's red, blue, or whatever. So we actually do a lot of those calculations here in this class, as opposed to doing it inside of our main op mode. Be able to abstract away some of that complexity. So we're going to make a new method here, public detected color, and we're going to call this one get detected color with no arguments. And we're going to make a new instance of a normalized RGBA color. That is something that the FTC SDK puts in. So how this color sensor works when you read it is, well, actually, let's go ahead and let's throw that in first. So we're going to say normalized RGBA of colors is equal to color sensor dot get normalized colors. So let's talk about what this actually does. This is going to return 4 values. It's going to return a fraction of a whole number of 1.0. And it's going to give you those 4 values. And it's going to give you red, green, blue, and alpha. Red is obviously, how red is the object, blue and green, so on. And then alpha is how bright, how much color is it actually returning back, or how much light is actually being returned back. So normalized colors is already going to normalize in to say that this is a fractional percentage of how much color that there is inside of the scene right now. But then one thing you'll find is that the light values inside of the space can end up changing your readings quite a bit, which is why they use this little white light. So if your sensor is designed, or your implement is designed so this always gets placed in the exact same height away from your distance sensor every single time, you're going to be good. So we're going to do a little bit more sanitizing here. We're actually going to normalize the value against the current alpha channel, against how much light is being actually read here. So despite already getting normalized values, we're going to go ahead and normalize it one more time against what our alpha is. And we're going to make 3 new floats here. We're going to say a float of norm red, norm green, and norm blue. And then we're going ahead and assign these right away. So norm red is going to be equal to colors dot red divided by colors dot alpha. And we're going to do the same thing for norm green is going to be equal to colors dot green divided by colors dot alpha. And then norm blue is going to be equal to colors dot blue divided by colors dot alpha. So now we've just normalized that, so no matter what the light value is, we should always get the exact same reading back. So if you're really close to the sensor versus really far away from the sensor, you should get the same reading. So now it comes to the point we have to do a little bit of calibrating here. So to be able to do that, we're actually going to add in a new argument here so we can grab in the telemetry object. And then for now, we're simply going to write telemetry.addData. And we want to add in what our current readings are for our red, green, and blue so we can know what the total values we need to be able to see in order to read these individual chips. So for that telemetry.addData, we're going to say red is equal to that norm red. And then we're going to do the same thing for telemetry.addData. We'll say that green is equal to the norm of green. And then the same thing dot add data for blue is equal to that normalized blue. And then because we have to return a detected color for now, we're simply going to return detected color dot unknown because we're not sure what it is at this exact moment because we don't actually know what our calibration values are. So now that we've got our main sort of getter function, eventually we're going to come back in here. We're going to do add if statements for specific colors added. So we're going to come back and add these later, but we have to be able to calibrate what they are for our sensor first. So let's go ahead and go to our team code, and we're going to make a new class, and we're going to call this one Color Sensor. I'm going to put Color Sensor Test for mine. Inside of our public class, we're going to extend the OpMode, and our OpMode always needs two methods. We need a public void init, and we need a public void loop. So the first thing we need to do is we need to create a new instance of our testing bench. So we're going to say that our test bench color of bench is going to be equal to a new test bench color. And then inside of our initialization method, we're going to call that method that actually initializes our test bench color. So I'm going to say bench.init, and we're going to initialize this with the hardware map. So now we have access to that getter function. So inside that loop, we're simply going to say bench.getDetectedColor. And then inside this, we need to add in our telemetry point. So now we should be able to call this, and we're going to go ahead and build this over our control hub. And let's get out a piece of paper or start writing down what our values are for when we're doing red. So I'm actually going to go ahead and add this in our block comment here. So I'm going to put a block comment in. I'm going to say that red has the values of, and we'll say red, green, and blue respectively. Red, green, and blue. And we're going to make some tuples here, these values. Future Brad here, I forgot to put in at teleop at the top. It's not going to work if we don't put that in. So let's go ahead and build this again. Okay, so let's go ahead and grab our color sensor test. Initialize and play this, and we can see that our red values are between 0.7, 0.1, 0.2. I'm going to go ahead and I'm going to take the red chip now, and I'm going to hover it over that sensor. And I'm going to put it at a fixed distance each time so that I make sure it's not far away. And we can now see that our red values have now jumped up quite a bit. We're now at 0.08. But that's actually quite low. We want to have a little higher values than that. We can see that's 0.09, 0.05. So it looks like the gain on our sensor is actually a little bit low for this current, the amount of lighting that's inside our room. So let's go back and change that. So because our color sensor readings were so low of 0.09, even when the chip was directly on top, we would expect if the chip were directly on top of it, it would be almost close to 1 if it were a pure red. So we're going to play with the gain so that we can make our values a little bit larger instead of having to play with that. So inside of our test bench mechanisms package, we're going to go ahead and grab our color sensor dot set gain. So initially it starts with a gain of 1. So we can go ahead and jack this up to, let's say, maybe a gain of 4. And we'll go ahead and build this. And this just takes a little bit of tweaking until you can find a value that you're pretty happy with. You don't want to be completely maxed out and totally saturated. But you also want to be, in my case, so low in the gain that's doing such a low value back. So let's go ahead and run this again, the color sensor test. And we're getting a little bit higher now. We're getting about 0.1, 0.3. But even when I'm directly on it, I'm still only getting about 0.3. I'd like to get a little bit higher than that. So I'm going to go ahead and set that gain even higher. I might set my gain almost to 8. Okay, so let's go ahead and grab this. And that's getting a far more reasonable point. We're almost maxing, we're about 0.7 when we're above. So I think this gain is a bit more reasonable. So I'm going to put this at a fixed distance above where I think it would want to be at. And I'm going to actually look, and I'm going to see. Oh, come on, phone. Why are you so out of focus here? There we go. So I'm going to go ahead and I'm going to try to read what are these specific values going to be showing up at. So I'm just going to go ahead and lean that. And when I'm in this position, red looks like it's anything above 0.4. Green looks like it's above less than 0.3. So what I'm going to do is I'm going to say that if red is great, red has something that's like 0.35, and then green is 0.3, and then blue is 0.3 as well. So in this point, it is greater than, and less than, and less than. So I'm going to go do the same thing for what our green values is. But in this case, I'm actually going to be yellow. So I'm going to go ahead and swap the chips now out for yellow. And we're going to read what our values are here. So it looks like on yellow, our green is actually going to be maxed out. So our red is going to be greater than 0.5. Our green is going to be greater than 0.9. And our blue values are going to be less than 0.6. So when I look at my driver hub here, when I said greater than 0.5 on red, greater than 0.9 on green, and then less than 0.6 on blue, you can see I'm actually fudging the range a little bit there, so that as I change that range, it keeps track of, it's never going to be exact. So that's the colors going to be returning for yellow. We'll go ahead and we'll swap this out with our blue value here. So now I'm going to go back into my desktop again. I'll write in my values. And in my case, red is going to be less than 0.2. Green is going to be less than 0.5. 0.5. And blue is going to be greater than 0.5. So now we can actually go ahead and work with our colors here. So we can say that if norm red is greater than 0.35, and norm green is less than 0.3, and norm blue is less than 0.3, then we can return detected color dot red, because we know it's going to be red at this point. Oops, a semicolon at the end of that. And we can go ahead and do the same thing with our current logic here. Now, you don't want to be too tight. You might have to play with some of these ranges as we go. So we'll say that else if norm red is greater than 0.5 and norm green is greater than 0.9 and norm blue is less than 0.6. We know that we are going to be on yellow, so we're going to return detected color dot yellow. Then we'll do another else if here. Else if norm red is less than 0.2 and norm green is less than 0.5 and norm blue is greater than 0.5. We're going to return detected color dot blue. And then if all else fails, if none of these are inside any of those cases, we're going to return detected color unknown. So now we can actually go ahead and comment out these telemetry data, because we shouldn't, well, actually, let's keep those telemetry data for now. When we actually run into the main code, we can comment these out, so we don't actually need these consistently printing for us. So now we can go ahead and make a new variable here up on our main color sensor. We're going to make a new one. We're going to say this is going to be a new detected color of detected color. And inside our loop, we're going to go ahead and read this. So we're going to say the detected color is equal to bench.getDetectedColor. And then we're going to say telemetry.addData. And we're going to say color detected. And it is going to be the detected color. So now we have a really clean main loop where we're just going to read our detected color and we're going to actually output that. So let's go ahead and let's run that and see if that outputted statement is what we would expect. Okay, so let's go grab our color sensor test, and we would expect that right now our color detected is unknown, at which point it is stating unknown. When I pull that blue statement up, we now notice that that color detected changes to blue. If we change that chip over to yellow, it's now saying color detected is yellow, and it's now changed its chip over to red. So that is exactly what we expect. So your next task here may be to tune your chips so that you can get a little bit more accurate with your colors here. And if you're too close or too far away, you may find that your tuning is a little bit off. So that is now your next challenge, is to see if you can change your tuning values so that you are consistently getting the same color readings all the way throughout your code. So I hope you found that helpful using REV's new Color Sensor V3. If you have any questions, let me know in the comments down below. Otherwise, I hope you found this tutorial helpful, and best of luck out there this season.